The world economy is a collection of numerous processes that are acting at the same time and are interdependent. There are many chicken and egg problems. Supply equals demand, output is distributed into consumption, investment, net exports, governments, consumption, and so on. So you have many identities, and if you look for such fundamental questions like what is the source of economic growth, resolving this chicken and egg problem is often very difficult. There have been many approaches to these questions in economics. Let me just concentrate on one. The supply side approach concentrates on factors of production, and typically in economics you would have capital and labor. Maybe in some more sophisticated ways you would have skilled labor and unskilled labor, or you would have various forms of capital. Now, if you look further back in time and you would like to cover also pre-industrial eras, you may also notice that agriculture requires agricultural land. And I would like to argue that in fact you have a very interesting insight on the development of the human civilization in the longest possible run if you organize the factors of production differently. My way of putting this is to specify hardware and software. There have been many theories of economic growth. In particular, Paul Romer won his Nobel Prize to a certain extent thanks to observing that technological progress is a source of increasing returns to scale because ideas are non-rivalrous and can be used simultaneously with various processes. So this insight is very important and I would like to build on it here, but I think that if we were to look at the longest possible time perspective, it is important to move away from the standard capital and labor framework and instead view hardware and software as the key factors of production. Growth is achieved through purposefully initiated physical action. In fact, all productive actions need both the physical part and the information part. So everything that performs the physical action will be lumped in my approach to hardware, and everything that is responsible for providing the information, for providing the code, will be lumped as software. Hardware and software are complementary. You need both to produce. They are also both essential in the sense that if you don't have sufficient supply of one of the two factors, you would not produce anything. Within hardware and software, though, factors are substitutable. So you can substitute human physical work with machines, and you can substitute human information processing with machine information processing. It's a nice thing to observe where growth comes from in this framework. Growth is about the accumulation of useful information. Information is non-rivalrous, that's Paul Romer's observation. Information is therefore a source of increasing returns to scale and an engine of growth. So in the hardware-software framework, all growth is because of information processing advantages. All technological progress is software augmenting. It's precisely the information character of software that makes software a natural candidate for an engine of long-run growth. So in the previous episode, I have argued that the drive of growth is our human actions, and our human actions succeed in generating growth because, first of all, we have come through the cognitive revolution and we can accumulate knowledge cumulatively as a species. The second reason is that we have learned to accumulate also hardware. We learn to benefit from the physical work performed by animals, then we learn to accumulate land and to draw energy from agricultural produce, and then after the Industrial Revolution we learned to gain energy from fossil fuels and to build machines that use this energy to perform productive action. Now, that's a novelty in our human history. Since the digital revolution, we are also learning to harness information processing capacities of programmable machines, such as computers and so on, and to outsource some of our cognitive operations to this sort of external machines. What outputs do we produce, and to which extent they require physical action, they require the usage of hardware, and to which extent they just require information processing. Okay, so first of all, we produce consumption goods, and these can be all sorts of consumption goods, from agricultural produce to manufactured consumption goods to cultural goods, okay, which can be produced digitally. We also have investment goods, and these are again physical investment goods, machines that produce for us or replace some older machines and so on. You may also think of investment goods in terms of digital technologies. So the bottom line here is that all sorts of goods that we produce require both hardware and software, although in different proportions. Okay, some goods really require a lot of energy and a lot of physical action. Some other goods require much more information processing and much more data. If you compare industrial manufactured goods to digital goods, now data is the new oil. Data replaces energy as the key raw material transformed in the productive process. There are many mechanisms that can potentially affect the pace of economic growth. The question is, though, which ones of those mechanisms are self-reinforcing and capable of giving rise to a self-accelerating feedback loop. Many processes would naturally die down. Like if you think about capital accumulation, there are decreasing returns. If you think about human capital accumulation, well, we can really learn a lot, but our brain capacity is finite, and our day has 24 hours, so we can do as much as we can do, and we cannot have our skills increasing forever. Okay, so if you were to identify the main sources of growth, you would need to find a self-reinforcing feedback loop, and that's why Paul Romer's observation on the non-rivalry of ideas is so important in this context. So it's good to run through all the eras of technological development. If you think about hunter-gatherers, well, their life was rather simple, so their whole hardware was their brawn, their muscle, their bodies. Okay, then their software was their brains, was the information they had about the world and the ability to act on this information. In the agricultural era, people learned to change the ecosystem, so there was new hardware factor, namely the new hardware factor was agricultural land. On the software side, it was still about human brains. After the Industrial Revolution, we learned new ways of putting machines into productive work, so then we had various forms of physical capital, productive machines, and that vastly increases our stock of hardware. Still, software again was the skilled work of basically more and more skilled workforce. After the digital revolution, a major leap happened, because for the first time in history, we have decoupled information transmission, information processing, and storage from human brains. Well, okay, we have had storage in the forms of books and for a longer time, but information processing was really always in our brains. Now things have changed, so we have a broader set of possible software. Now we also have computers, we have smartphones, we have robots. Okay, we have various sorts of devices that include digital chips and are able to process information on their own. In one of the earlier episodes, I argued that technological revolutions in a drastic way affected the availability of either hardware or software, and that they happened in an alternating fashion, like a great pendulum swinging between hardware and software. And that's because each of those revolutions worked to reduce a certain scarcity. The cognitive revolution reduced scarcity in software, in the human brain capacity, and unleashed a source of growth thanks to the accumulation of knowledge about the ecosystem. The agricultural revolution affected the scarcity in hardware. It enabled us to farm land and therefore produce many more calories per unit of land area, and therefore the agricultural revolution dramatically increased our ability to perform physical action. Now, the scientific revolution again swung the pendulum towards software, and that was a major leap in our ability to process information as a group, as a species, as a society, and that again accelerated growth thanks to development of science. The Industrial Revolution was a major leap in our ability to obtain energy from fossil fuels and use this energy for productive use, a major improvement in our capacity to perform physical action. And now, again, going back to software, we're having the digital revolution, and now we have resolved the scarcity of information processing abilities thanks to outsourcing part of the data processing outside of human brains. Technological revolutions are about reducing the existing scarcities in production factors. And the hardware-software model is a useful tool that can easily identify where the scarcities are. So think about the year 2020, okay? Think about the current moment. What do we perceive as the key scarcity at the global level at this time? Is it hardware or is it software? My perception is that we are lagging substantially with our software behind our hardware. We have already begun the digital revolution, but we are at a relatively early stage of the digital revolution. We have much more processing power now than we had before because we have all these internet-connected CPUs, okay? But we don't yet have algorithms that could efficiently harness this power. If I were to predict the future, which is of course difficult, in my view, what we should expect in the future is rapid progress in that what is scarce at the moment, okay? And that is software. So I expect major leaps in probably AI, because that's the type of software that can learn by itself. So there is the saying, what Intel giveth, Microsoft taketh away, okay? So this is a funny saying that was meant to represent that we have more and more computing power in our computers, but essentially our applications are not as efficient as they could have been, and so we may have like 16 times more computing power every decade or so, and yet we do basically the same things with our computers. Well, not exactly, of course, but you may say similar things. So is this going to change? I think it is going to change, but I think the only channel through which it can change is AI. And of course, there have been important breakthroughs in this regard. We have deep neural networks, we have generative adversarial networks, and this kind of architectures that broadly mimic the structure of the human brain, but very broadly in some basic characteristics, but then it's all about learning. It's all about feeding a lot of data into these algorithms so that they can hopefully learn and achieve high performance in certain tasks. Okay, so far we only have narrow AI with very narrowly specified tasks, but the tasks can possibly become broader and broader as time progresses. The hardware-software model also provides a beautiful conceptual distinction between automation and mechanization. Okay, mechanization is the replacement of people with machines within hardware. So people used to do things with their hands or with the help of some domesticated animals, and later machines do that, and that's mechanization, and that's been happening throughout the world since the Industrial Revolution. Automation, by contrast, is replacement of people with machines within software. Automation takes place in moments where there were processes that previously needed human cognitive work to be performed. And now they can be automated, they can be performed without human inputs, without human thought, without human supervision. Whenever you hear questions like, will a robot take my job? Or will humans go the way of horses? Keep in mind the difference between mechanization and automation. Okay? Horses were useful for performing physical action, not for their cognitive skills. So horses are now obsolete, but probably our own physical labor to a large extent is also obsolete. But what really matters is how obsolete our brains will become because of progress in AI. And that is an open question. Okay, so to wrap up, is this a good theory of economic growth and technological progress? Well, we don't know. It's clearly a falsifiable theory. It delivers clear predictions on sources of growth, on mechanisms that lead to economic growth, but whether the data will confirm the theory or will falsify the theory, we would have to wait for that. Clearly, an important advantage of the hardware-software model is that it unifies a lot of frameworks that we have known in economic growth theory. It can be seen as a generalizing model that also features, as special cases, the standard model of growth with capital and labor, also features the model with capital-skill complementarity, with skill bias technical change, and also unified growth theories that reach back to pre-industrial eras, like, for example, the agricultural era, or even further back to the hunter-gatherer era. So it is a good candidate as a unifying structure. Whether it's a correct unifying structure, or maybe there is a simpler structure that could still unify all the eras, or maybe this structure is too simple, again, data can only tell. Fun fact: why do we develop all these technologies? Well, as I argued before in some previous episode, we like to accumulate resources, and we like to improve our capacity of controlling the world. That is, our drive of local control maximization. So we do this to help ourselves, and we produce machines that are capable of performing physical work. We also now produce machines able to perform cognitive work. Evolution produced our species and produced the local control maximization process that is run by our species, and this process has escaped the grip of evolution. Now, while we are producing all these fancy data processing algorithms, we may also one day produce an AI process that will be sufficiently capable that it would also escape the grip of our local control maximization process. And it will generate its own process, growing at its own pace, orders of magnitude faster. Should we fear that? I don't know. Just saying. This is probably done by a human, but I thought at the first glance that it was beavers. Incorrect!